All right, so we have another problem. And I'm intentionally varying the problems so they're not all similar right in a row. Because again, the approach to the problem is what is most important. So we have a piano, we know its mass. I'm going to draw a rough sketch. Here's my piano. It is being lowered into position. So it has a velocity headed downwards. It's being lowered by a crane. So there's some sort of force from the crane pulling upwards on it, while two people steady it with ropes pulled to the sides. So Bob's rope pulls to the left. His rope is angled 15 degrees below the horizontal, so I'm obviously not drawing this to scale. Has a force of 500 newtons. Ellen pulls to the right. And we know she's pulling at an angle of 25 degrees below the horizontal. So the first question, what tension must Ellen maintain in her rope to keep the piano descending at a steady speed? At a steady speed, so straight down at a steady speed means the acceleration is 0. This is an example of what we would call dynamic equilibrium. Equilibrium meaning there's no acceleration. Dynamic meaning there's motion. But nonetheless, we still approach the problem the same way. We know having no acceleration means there's no net force. So the forces need to balance out in the x direction and the y direction. So I'm going to draw a better picture of my free body diagram. So the crane we know is somehow holding the piano up. I'm going to just call that F sub C. So force of the crane. We know Bob is pulling. I'm going to call this F sub B, force of Bob. We do know this force is 500 newtons. And the problem tells us that this force is angled 15 degrees below the horizontal. Ellen, we're trying to find out how hard Ellen is pulling. We do know the angle. Now there's one other force. That's our field force of gravity. So mg. So force of gravity, always pulling straight downwards towards the center of the earth. The ropes attached to the piano, so Bob's and Ellen's, and then the rope or cable, however the crane is holding the piano upwards. So our free body diagram. We always want a free body diagram. These are going to be required on your exam. So be sure you're practicing them as you do the homework. From here, because we have an acceleration of 0, because the problem specifically states that they're keeping the piano descending at a steady speed. So descending meaning moving downwards, steady speed meaning not speeding up or slowing down. So from free body diagram, we're going to look at the x direction and the y direction. We know there's no net force in either direction. And so the forces need to balance out. Excuse me. In the x direction, we know Bob's rope is pulling to the left and Ellen's rope is pulling to the right. So we can say force Bob X has to equal force Ellen X. So let's see here. Bob's force is 500 newtons. That is adjacent to the 15 degrees. So 500 cosine 15 is going to be the x component of Bob's force. In the x direction for Ellen, we don't know how hard she is pulling, but we do know the angle. So this x component will be her force times the cosine of 25. That's nice. We can actually solve for Ellen's force right now. So cosine 500 times the cosine of 15 divided by the cosine of 25. I'm going to write this out with a number of sig figs first. I'm doing that to use that value in the y direction because that will be important. As far as the answer to part A, I would round. We have 2 sig figs. I always assume there's a decimal place, like the 500 newtons. I'm just assuming that that's 3 sig figs, 500 kilograms, 3. So 15 and 25, that gives me the lowest significant figures. So I should be 530 newtons in terms of sig figs. So that would be my answer to part A. But I don't want to use a rounded value when I have to calculate for part B. Since the main cable is acting vertically upwards, we're going to be able to find that value looking and balancing out the forces in the y direction. So in the y direction, looking at our free body diagram, the cable is pulling up, Bob is pulling down, Ellen is pulling down, gravity is pulling down. So to balance the forces, I would say that the force of that crane upwards would need to balance out with the y component of Bob's pulling force, so just this downwards component, the downward component of Ellen's pulling force, and then gravity. All 3 of those are pulling downwards. Well, since we know Bob's force is 500 newtons, the y component is opposite that 15 degrees. So we know that force is 500 sine 15. Ellen's force over here, we've now calculated that her force, 532.89, that represents the hypotenuse over here, the actual total pull. We need specifically the y component because we're balancing the forces in the y direction. So we need to multiply that by sine 25. And then the force of gravity being straight down, the problem tells us that the mass is 500, and then G, of course, is 9.8. So plugging these numbers in, my calculator is telling me this. In terms of 2 significant figures, I like to write mine in scientific notation to round correctly. So writing it as 5.3 times 10 to the 3rd newtons would be fine. If we wanted, we could say 5.3 kilonewtons or 5,300 newtons. Any of those is valid. They all represent the same thing. And so the cable is pulling upwards, 5,300 newtons in this situation. So again, free body diagram. Set up your symbolic equations. So before plugging numbers in, just what we mean by the net force equaling 0 in this case with no acceleration.